Good evening, everybody. Thank you for attending this talk. First of all, I'd like to thank the Pista ng Mapa 2020 organizers for including our work in this conference. For tonight, I'll be discussing TanawHorama, an image processing workflow using open source technologies to display panoramic views. Output of this workflow will appear similar to views we see when we use Google Street View. As we will see later, the images can come from a variety of sources such as normal phones and laser scanners. However, much of the focus of this presentation will be on images captured using drones. Just to put some context on why I am making this presentation, I'm a land surveyor with several years of experience in managing UAV operations for a utility company, and we've been using drones almost every week for the last 4 years. In case you want to know more about me, just search me in LinkedIn and feel free to connect. So you'll know the flow of this presentation. This is how we'll go about it. We'll start with some definitions, then we'll go to why we developed the workflow, and then we'll demonstrate the actual workflow to generate the panorama view from the oblique images. And then finally, we end with the conclusions. Okay, I think we can begin. TanawHorama is just a play on two similar words, Tanaw and Horama. Tanaw, which we all know is a Filipino word that pertains to sceneries or the act of looking. And Horama, the root word of the word panorama, which is a Greek word, and it also means to look or to prospect. Now, why do we need to talk about processing of images from drones? Basically because UAVs are very popular now, and I'm assuming that more than a few of us who are attending Pista ng Mapa 2020 are also UAV users. And several studies and researches also show this trend, as we can see on the image on the left. Majority of the industries are now using drones in their businesses, and it's already about a $12 billion industry now. Also, based from personal experience, most survey requests that my team receives now require some form of UAV observations, in addition of course to traditional measurements like GNSS and total station observations. Usually when we are asked to conduct UAV observations, they fall into two general categories: engineering surveys and site visualization. Engineering surveys is the more popular between the two, especially for us surveyors, because it's the mode that produces base maps, DSMs, and DEMs. Accuracy is the focus of this type of surveys. The second one, site visualization, is the type of UAV observation wherein the focus is more on getting insights about the site conditions of the project area using oblique shots. For example, on your lower right, you see there an oblique photo, and the water level with respect to the intake tower wouldn't be as obvious if we're looking at it from the nadir. Unfortunately, this type of observation is often dismissed as unimportant, especially when compared to engineering surveys. However, we have to recognize that this type of observation gives a more intuitive and natural way of providing information through UAV observations, because it somehow mimics the usual way people look at things. And this is very helpful, especially to non-technical stakeholders who will use your data. Kasi, diba, hindi naman tayo parating tumitingin. vertically downward. We always look at angles with respect to the horizon. Needless to say, having both engineering surveys and site visualization gives a more complete data story of our project site. Here I'm just showing the well-established image processing workflow needed for base map generation. This workflow can also be done using open source technologies such as Visual SFM and QGIS, but I won't be discussing this too much since it can be another presentation topic all by itself. So how about for panoramic views? For actual field surveys, I'll just go through this quickly. It's usually done in normal or manual mode, or if your drone supports it, through a single waypoint flight plan. For the normal mode, you just fly to a spot, set the pitch of your camera, and take photos just like you would using a normal camera or a phone. Just make sure you have sufficient side overlap. For the single waypoint method, it's just the same for the manual mode, but you just do it automatically. We now go to the important parts of this presentation. In processing images to generate panoramic views, what we usually have are OTS or off-the-shelf proprietary software that are costly and with relatively high learning curve, especially for casual users, that are impractical to deploy to numerous stakeholders who will just view your UAV observations. With this in mind, we developed a workflow that solely uses open source technologies that is scalable, which means that the number of users can be dynamic and accessible because the end users only need their web browsers to view our results. This is the TanawHorama image processing workflow. We'll be using Hugin to process our images into a stitched panoramic image, and Pannellum, which is a JavaScript API, which will render our panoramic image that can be viewed interactively using any web browser. We'll start the process flow with Hugin. You can download Hugin in the link shown in the slide. Just choose the right installer for the system that you are using. Hugin is pretty straightforward to use. For this example, just to make it simple, I just use shots that I have taken in one of my mountain bike rides in Sierra Madre. And in consideration of time, I will just be showing screenshots instead of showing the actual process using the software. First, you just load the images that you want to stitch. And then set the focal length of the camera that you are using. For my phone, it's 28mm. After that, just set the lens type of your camera. For me, it's rectilinear. But there are many options that you can choose, such as cylindrical and stereographic. You can play with it as you become more familiar with the software. After that, just click Align and the software will do the image matching for us. The duration will depend on the number of images that you've loaded. Finally, after the images are matched, just click Panorama and the final stitch image will be created. This is the generated panorama from the sample workflow that I've shown. Now I'm sure some of you are now wondering, bakit ko pa kailangan gawin yan eh? Kaya naman yan gawin ng phone ko or kaya naman yan gawin ng DJI Media Maker ko. Well, unfortunately, not everybody uses new DJI drones and not everybody has smartphones. For example, kami pagka malayo yung survey location namin, medyo impractical na smartphone yung dala kasi yung battery mabilis maubos. So what we use are just normal phones. So this process gives us another option for a more generic workflow, and as can be seen in the example, this is a procedure that can be used to a variety of sensors like laser scanners, smart total stations, and even traditional cameras and dumb phones. More importantly, this workflow is very useful for UAVs that have no automatic single waypoint flight mode that are just controlled manually when obtaining perspective views. We now move on to the next step in our workflow. After stitching our images, we now find a way to render the panoramic view through a viewer. For this, we will use Pannellum API, which can be downloaded from the link shown in the slide. Since the API only works through a web server, we'll need to link the downloaded API in our HTML, as can be seen in the red box. For the code, you can use the tutorial in Pannellum's website to just copy the link for the downloaded files or for the CDN link. After that, set a container for the panoramic view. This is where the processed panoramic image will be displayed in your browser. For this example, I have used the div element using HTML and CSS Bootstrap to tell the browser where to render the panoramic view of the stitched images. Finally, we just set the parameters that we've used in processing the images. This is where we also tell the browser where to look for or where we have stored the processed image. We now take a look at the generated panoramic view. Okay, so we've now processed the images from our phone using Hugin to create a panoramic image, and we've already told Pannellum how to display it on a web browser. So all we need to do now is to click this button, and then Pannellum will automatically generate the panoramic view using the image processed by Hugin. So ito na yung ginawa natin kanina. I have another sample here, but this one is using images from a drone. So as you can see, the view here is 360 degrees, and without installing any new software and just by using your browser, you'll be able to visualize your survey site using open source technology. Another advantage of using this workflow is that we can link the generated panoramic views, which shows perspective views of our project site, with our GIS that contains the base map generated from our engineering surveys. The GIS base can also be created using open source technologies like Leaflet API and QGIS. As mentioned earlier, combining these two gives a more holistic view of our project site that can deliver previously unseen productivity insights at our survey area. Kaya nga sinabi ko kanina, a more complete data story. Let me show you an example of a combined web map. Here's an example of a combined web map wherein the pop-up points indicate the survey areas. And here, using Pannellum API and Leaflet, we can combine the information gathered from engineering surveys with the perspective view surveys. So for example, we have here a point in somewhere in Pasig. So we've loaded the base map generated from UAV observations, and we've linked it with the perspective view generated using Pannellum API. So in conclusion, we have seen how we can use open source technologies in generating panoramic views from images. The detailed workflow was demonstrated wherein Hugin was used to stitch the images and Pannellum API was used to render the panorama in a web browser. Hopefully, we have also realized that combining information derived from base maps with those from perspective views give a more complete data story of our project site. With that, thank you for your time, and I'm hoping you've learned something from our work. Feel free to email me if you have questions related to the presentation. Here are the references I used in this presentation. Good night and have a fruitful and enjoyable Pista ng Mapa 2020.